Good afternoon and welcome back. In this section, we will demonstrate the logarithmic law of change of base with practical example 6. The question reads, log 4 base root 2 plus log, log root 27 base 9 minus log 1 over 5 base 5. And the options are there. A, 3 over 4, B, 1 over 2, C, 5, 3 over 4, and D for 1 over 2. We are going to demonstrate the logarithm of change of base with this question. As you can see, the questions are not in the same base. All the components of the question are not in the same base. The first component, log 4 base root 2, is in the base is root 2. And the other second one, the base is 9. While the third component, the base is 3. We are going to take a practical example of how to demonstrate the logarithm of change of base. Now, we will not come and start to solve questions here. Before we do anything in logarithm, we must first of all play with the laws of logarithm. And that is going to be our starting point because of those who have not been able or not opportune to get some of our previous tutorial. And we'll go now to start to play with the law of logarithm. Now, there are about 7 laws of logarithm depending on how you coin it. The first identity or law of logarithm says the log of 1 is equal to 0. The log of 1 is equal to 0. That is, log 1 base 2 is equal to 0. Log 1 base 10 is equal to 0. Log 1 base 15 is equal to 0. The log of 1 is equal to 0 no matter the base. The next identity says log of the base is equal to 1. Log of the base is equal to 1. That is to say, log A base A is equal to 1. Log 2 base 2 is equal to 1. Log 3 base 3 is equal to 1. The log of the base is equal to 1. Now, the third law, the law that tells us, or we call it the product law of logarithm, says log xy, that is the log of x multiplied by y, is the same thing as log x plus y, all in base a. The fourth law, otherwise known as the quotient law, is the law that tells us how to divide logarithm. It says log x over y in base a is same as log is same as y x minus y all in base a. Now we go to the next law. The next law there says we call it the law of power. Says log n raised to power n is equal to n log x. Log s raised to power n is equal to n log s. That is the law of the exponent of power. The log of s raised to power n is equal to n log x. Then the third one is the root. It says the nth root, the log a to the the n log of the nth root of y base a is the same thing as 1 over n log x base a. Now we now go to the seventh rule. The seventh law says log x base y is the same thing as log x over log a all in base c, where log s is a number, a is the old base, and c is the new base. This is a law used when we want to change the base of logarithm. Now, what is saying that log x base a is the same thing as log x over log a all in base c. That is what that law is saying. But that is to say, it say log a, log x over log a all in base a is same thing as log x over log a all in or base in the new base. That is what that law is saying. We are going to do practical uh, example with this law in this question. Now we go. That is what it's saying. That is to say, log b base a changing to log to base base k is the same thing as log b over log a all in base what k. And log 4 base root 2 is the same thing as log 4 over log root 2 all base in all in base 2. That is to say, it is the same thing as log 4 over root 2 in base 2. Log 4 over root 2 in base 2. We are going to exploit this law in this question. So on this note, we are going to bring back that question and attempt to solve it. That question reads, log 4 root and log 4 base root 2 plus log root 27 base root 9 minus log 1 over 5 base 5. So we are going to go back to that question and attempt to solve it. We are going to apply the logarithm law of changing base. Do not forget that log 4 base 2 now the question log 4 base root 2 plus log root 27 base 9 minus log 1 over 5 base 5. Now we are going to start this question part by part. We first of all do the first part, which is log 4 base root 2. We are going to change the base. You discover that log 4, the base is root 2. Root 2 cannot form a proper base, so we are going to change the base. And how do we know the base we are going to change? Now you look at the roots, the base, and you look at the number. There's a relationship between 4 and 2, because 2 is a power of what? 4. 2 times 2 is equals to what? 4. So we are likely to change the base of this log to base 2. And changing the base to base 2 will be like this. Log 4 over root 2 all in base 2. Finish. The log of the number over the log of the base all in the new roots. That is just what we need to do. So we go ahead. So we have root 2, log 4 base 2 over log root 2 base 2. We have changed it already. This is how to change it. Then what next are we going to do? We are going to evaluate this. You know, the log log 4 base 2 is same as log 2 raised to the power 2 base 2. Then log root root 2 base 2 is same as log root 2 raised to power 1 over 2. That root 2 is same as 2 raised to power 2 base 2, which is equals to 2 log 2 base 2 over 1 over 2 are log 2 base 2. Yes, log 2 base 2. 2 log 2 base 2 is equals to 1 because it is 2 times 1. The log of the base is equals to 1. So 2 log 2 base 2 is equals to what? 1. It's equals to what? 2. 2 log 2 base 2 is equals to 2. The other one, 1 over 2 log 2 base 2 is same as 1 over 2 times 1. So it's going to be 1 over 2 because the log of the base is the log of the base is 1. So it's now 1 over 2 times 1. And 2 over 1 over 2 is the same thing as 4. Yes. 2 over 1 over 2 is same as 4. That it is 2 divide 1 over 2. And when fractions divide each other, you invert the other one and multiply. It becomes 2 times or multiply by 2 over 1. 2 times 2 is 4. 4 over 1 is 4. That's how we arrive at that 4. That's how we arrive at the 4. Then the second section, log root 27 base 9 over log 9 base 3. Now we have changed it to base 3. Why did we change it to base 3? Why did we change it to base 3? We changed it to base 3 because there's a relationship between 27 and 9. 27 and 9, the relationship there is 27, 27 is to the power of 9, or 3 is to the power of 9, and 9 is also to the power of 3. That's so the base, if we change it to base 3, 3 is 3 times 3, which is 9. 3 is, times 3 is equal to 9. And 3 raised to power 3 is equal to what? 27. So that is why we need to change it to base 3. As we look at the relationship between the base, that is 9 and 27. And the best base to change it to is base 3, because 3 is a power of 9 and 3 is also a power of what? 27. So that means the root is 1 over 2. It's going to be 1 over 2 times 3. 1 over 2 times 3 over log 3 raised to power 2 base 2, which is invariably 1 over 2 times 3 log 3 base 3. 1 over 3 times 3 log 3 base 3 is the same thing as 1 over 3 times 3, because log of the base is equals to what? 1. Log of the base is equals to 1. That is 1 over 2 times 3 log 3 base 3 is same as 1 times 3, 1 over 2 times 3 times 1. It remains 3 over 2. That is 1 times 2, 1 over 2 times 3 is 3 over 2. Then the bottom part, which is 3 log 3 base 3, 2 log 3 base 3 is same as 2 times 1 because log 3 base 3 is equals to 1. So it is 2 times 1, which is equals to 2. So we now have 3 over 2 over 2 as the answer, which will invariably give us 4 over what? 3. Then the last one is log 1 over 2 base 5. It's already in base 5. So we just um, evaluate it. It becomes minus 1 log 5 base 5, which is what? Minus 1. Now, the first expression, we got 4. And the second expression, this one I'm pointing to, we got the answer 3 over 2 over 2, which is 3 over what? 4. And the last expression, the one in the yellow color, the final expression there is minus 1. That is to say, 4 plus 3 over 4 minus into minus 1, which will give me 4 plus 3 over 4 plus 1, which eventually will give me 5 whole number, 3 over 4. And that is the answer. Now, there is an alternative method of doing that, of solving that problem. And I want to also expose you to the alternative method so that anyone you find easier, you adopt it, especially in an exam situation. So the method is the same way, but in a different dimension. We are going to still change them into different base and solve it out. Now the question again, log 4 base root 2 plus log root 27 base 9 minus log 1 over 5 base 5. Yes. Now, this is what we are going to do. We are going to change log 4 base root 2 to 4 over root 2, or in log 2, base 2. So we say change to a new base. We want to change it to a new base, and the new base is base 2. And to change it, just log of the number over log of the base, all in the new base. Become log 4 over root 2, all in base what? 2. Log 4 root 2, log 4 over root 2, all in base 2. Simple. Then what are we going to do now? We are going to look at the relationship between 4 and 2. And 2 is the power of 4, and 2 is also in the power of root 2, so 2 is the new base. Then what we need to do now is to write this number in the power to the power of the base. That is 4. How many 2 is in 4? It's only 2. So we have 2. Then how many 2 is in the root 2? There is half. That is 1 over 2. So that question now, that is log 4 over log root 2 is going to be equal to 2 over 1 over 2. Yes, it's going to be equal to log 2 over 1 over 2. So that is what we are doing. So we are going to write the power, we are going to rewrite in the power of the base. To write in the power of the base, we how many times with 2 times itself to get 4 is 2. So the numerator to that one is now 2. How many times with 2? 2 will raise itself to become 4, it is 2. 2 raised to power 2 is what? 2. So we write 2 as the numerator. Then how many power is 2 to root 2 is 1 over 2. And that is all. 1 over 2. So it becomes 2 divided by 1 over 2, which is 2 times 1 over 2, which eventually becomes what? 4. Now we go. The same thing we are going to do in this other question. The other question we are going to say log root 27 over log 9, all in base what? 3. Log root 27 over log 9, all in base 3. Log root 27 over 9, all in base 3. Now we find out how many times, what is the power of 3 to 27? The power of 3 to 27 is 3, but hold on. Wait a minute. Do not forget that there is a root there. So the root will first of all come out to become 1 over 2, then multiply by the power of 3 to which 27, to which 3 will be raised to give you 27. So the first thing we're going to do there is to first of all bring out the root. The root become 1 over 2 multiplied by the 3 to which 3 is raised to give us what? 27. Do not be confused. So we go ahead. So it becomes 1 over 2 times 3 log 1 over 2 times 3 over 1 over 2 times 3 over 2, because 3 is raised to power 2 to give you 9. 3 is raised to power 2 to give you 9 over 2. 1 over 2 times 3 over 2. And that is all. 1 over 3 times 1 over 2 times 3 will give you 3 over 2. And 3 over 2 divided by 2 will give you 3 over 4. And 3 over 4 is the solution to that expression. Now the other one, which is already in base 5, we just want to use to change it. Normally it will be the same thing. It's going to be log 1 over 2 over 5 in base 5, all in base 5. So what is the power of 2 to 1 over 2 to 1 over 5? The power of 5 to 1 over 5 is minus 1. And the power of 5 in 1 5 is 1. So that one will give you minus 1 over 1. 1. Minus 1 over 1, which is equal to what? 1. Now what we do next? You discover that all the expression log 4 base root 2, the solution is 4. And the expression log root 27 of base 9, the solution is 3 over 4. And the expression log 1 over 5 base 5, the solution is what? Minus 1. Now we just need to bring out the plus. That is 4 plus 3 over 4 minus, first of all, bring out that minus, then what we have is minus 2. So it's going to be minus minus 2, which is same thing as uh, 4. Now, this is only, this is homework, classwork or practical question that you need to do. You need to do this question. You try to do it. Now, the first question reads log 3 base 9. Evaluate log 3 base 9. Second question, evaluate log 0.2, log 25 base 0.2. Why the last question reads uh, log 4 base root 2 plus log 16 base 1 over 2 minus log 32 base 4. Try as much as possible to attempt this question and hit us in the comment section. Should there be anything that is confusing you, I bet you will not hesitate to get back to you. Like our tutorial, share our channel, and subscribe. I thank you for learning with us. Bye.